Good day all, and welcome to another smashing DAG, the Aviator video. Please like, share, and subscribe. Cheers.
Hey folks, so this is video number 2 about this system simulator I created. And in this video, we're going to do a much deeper dive into each specific system. Now, in the future, I'm going to use this to make videos on how to program your radio, set up the S.bus system by Futaba, and just overall how to set up your radio control aircraft's radio system. So I hope you enjoy it. Rock on. But first, I want to do a shout out to my sponsor, RTL Fasteners. If you need bolts, nuts, blind nuts, Allen heads, anything for the hobby, they're going to have it. If you go to the website and use code DAG25, you'll get 25% off any order over $25. So use DAG25 and you'll get a good discount. So the first system I want to cover is this jack screw system, and it's kind of cool because one of the things I did is I used a voltage regulator that actually shows the amp draw on the motor. So it's interesting when you're wanting to move, let's say, swing a wing, or you're wanting to actuate a landing gear with a jack screw. You can actually see what your amp load is, and if you're really taxing either the motor controller you designed or you're taxing the voltage regulator. The next system is this leading edge device. Now, this was designed specifically for one of my aircraft to kind of mimic like the way the F4 or the A7 leading edge work. This is not a slat that's on a track, but just a leading edge device and how it works. This is the flap that I designed for my B-36, believe it or not, my 257-inch B-36. And this is really slick the way that the dual arms work to cause the flaps to move back and rotate. This isn't my own design, folks. This is the way the real B-36 are very close to the way the real B-36 is designed. But I just want to be able to show people flap activation, how to set their flaps, how to set the flap with the elevator and other things. And when I say set the flap to the elevator, what I mean is that many times when you put your flap down, your plane's pitch will change and you have to mix in a little bit of elevator so that you're not constantly trimming your airplane. So I'm going to cover that in a future video too. But right now I'm just kind of doing an overview of the different systems that make up this simulator. And it's a teaching tool, folks, and this is done the way I wanted to do it, but there may be a lot of other better ways to do it. Next, we're going to cover the ailerons and spoilers, and one thing to keep in mind is this is set up as if you have a servo in the right wing and a servo in the left wing for the ailerons, and a servo in the right wing and the left wing for the spoilers. Okay, I can also cover putting dual servos in one wing. And here is the elevator system, which I'm basically showing the right elevator, left elevator on a airplane that would have split elevators. Now, I know that one servo would be facing in here and the other one facing out if I'm really depicting how it is in a model airplane, but this is just for instructional purposes, folks. So, you know, I understand that this isn't actually perfect the way to be set up in a plane. Next, I'm going to cover the rudder. And this is a pull-pull system like I put on a lot of my big airplanes. My MSL2 with the 188-inch wingspan is set up this way. However, I'm only using one servo on it, which is like a 580-ounce servo. But this has dual servos. I'm also going to talk about how to use a single channel to do this or use 2 channels to do this. On this part of the simulator, I have 4 servos depicting 4 throttles on an aircraft. Okay, so these could be set up as 1 channel doing all 4 throttles, 2 channels doing all 4 throttles, or 4 channels doing each one so you can set the trim, which would be the idle. I've already gotten a couple of questions about this landing gear part of the airplane, and when I do a video, I'll think I'll be able to explain it a lot better. But basically, I have a nose gear here that's going to retract. I have the gear doors it's going to open and close via a sequencer. And then I got a nose gear steer over there. And one of the things I like to do on my airplanes is have an extra channel for the nose gear. That way, when I put the landing gear up, the nose gear is not steering. Okay, it shuts off the nose gear. And you'll see here that I'll turn the nose gear. When I flip the gear up, it goes to straight. And that way, the gear is pretty much not moving around in the gear well. Now, When it comes down, though, there's no delay on that nose gear, so you have to stay off your rudder until the nose gear is all the way down. But I'm going to get really deep into how I did this later on, folks. And here's the Bombay Doors I actually designed for my 257-inch B36. And this works slicker than snot, folks. This just worked beautifully. But I'm going to go into how to program the servos to move the degrees you need and all that kind of things in the future. And I wanted to make sure I covered air systems in this system simulator to make sure people understood how to set up an air system. Here I'm just kind of depicting it moving a canopy open and close. I like to put air systems on things that if something binds, it's not draining my battery through like an electric motor. But there'll be more to come on this. And here's the second air system, which is just like an air brake. Pretty simple design. And I just 3D printed a bunch of parts so that I could, make these easy to demonstrate, folks. It's pretty cool how air systems actually work. I really think they're very cool. And here is the actual servos that actuate the air system. If you look on the right, you can see the valves I use to pressurize the system. Then I have two instruments, the pressure gauges that show what the main tank pressure is. Then I have two regulator knobs that I can regulate the air pressure. And then I have the regulated air pressure. Now, right now, the air system's almost dead because I've been actuating the system so much. But I am going to go pretty deep on air systems. And then kind of lastly, folks, this is a S.bus system from Futaba that's running this system. I'm going to show how to actually program the S.bus servos and run them off this S.bus, how to program the SPD1s, which are the decoders that tell the S.bus system to talk to your normal servos, so you don't have to buy all S.bus servos. I'm going to talk a little bit more about my voltage regulators here, how I have the battery power side, and then I have the regulated power side. So there'll be a lot more to come in the future, folks. So I hope you like this video. Please like and subscribe. Have an awesome day, and I'll see you next time.